Audible இருக்கா வாய்ஸ்? ரீசெண்டாக வந்து இம்போர்ட் அண்ட் எக்ஸ்போர்ட் கம்பெனியில் வந்து ஃபினான்ஸ் மேனேஜர் வந்து தென் ஸ்ப்ரே பெயிண்ட்னு சொல்லிட்டு டச்சல் ஸ்ப்ரே பெயிண்ட்னு சொல்லிட்டு ரீசெண்டாக வந்து ஏஆர் ரமன் கூட ஆட் ஆகும் 3 லேக் அந்த ஸ்ப்ரே பெயிண்ட்டு ட்ரேடிங் பண்ணிட்டு இருக்காரு. ஸோ அவருக்கு சப்போர்ட் பண்ணுறதுக்காக வெளில வந்து ஒரு 2 இயர்ஸாக அதை டேக் கேர் பண்ணிட்டு இப்போ அதை வந்து மேனுஃபேக்சரிங் அண்ட் பேக்கிங் பண்ணி சேல் பண்ணிட்டு இருக்கோம் சென்னையில். அண்ட் தென் நவ் வந்துட்டு லிக்விட் பெயிண்ட்டுக்கும் எங்களுக்கு ரெக்யர்மெண்ட் அதிகமாக இருக்குது. கஸ்டமர் சைட்லேருந்து எங்கள்கிட்ட ரெக்யர்மெண்ட் கேட்குறாங்க. ஸோ வி ஆர் ட்ரைங் டு ஸ்டார்ட் அப் நியூ பிஸ்னஸ் ஃபார் லிக்விட் பெயிண்ட் மேனுஃபேக்சரிங். அண்ட் இடம்லாம் பார்த்து மிஷின்லாம் ஆர்டர் பண்ணி ரெடி ஆயிடுச்சு. கெமிஸ்ட்ரியில் எனக்கு ஒன்றுமே தெரியாது, ஐ எம் ஜீரோ. பட் ஓவரால் நாலேஜ் வச்சு தான் பண்ணிட்டு இருந்தோம். தென் Ramanathan sir has joined.
By the way, Surendra Bhattal, he is from Nepal, so he may not know our Tamil. Anyway, yes, today's session will be a mixture of both Tamil and English, and I'll try to translate as and when required. Okay. So here you can see our students who are studying BSc Chemistry, and they come here for doing their metal finishing project. So I thought of introducing them to you so that they can get inspired. And let me introduce Surendra also. So he is from Nepal. And you can explain how you were attracted towards paint finishing or metal finishing, so that these girls will also be interested, and we may not know, they may also become a great metal finishing entrepreneurs, and they will be competitors for you also. Yeah, you can start, Surendra, you can explain. You are, how you are inspired towards paint.
First of all, my name is Surendra from Nepal, Pokhara. I just researched one years ago about Ramanathan sir, and as in Nepal is growing the paint industry, so I think I have to study or do research about it, and so that's the reason why I want to, as entrepreneurship also, and I want to establish in paints and give new concepts. That's it, sir.
Okay, thank you. And Prakash was explaining about his entrepreneurship and his ventures. You can continue, sir, please.
Yes. Let me continue in English so that Surendra can also.
Yes. Thank you.
There will not be any other translation.
English is the common language. So, everybody knows. Right.
So we have started we are planning to start a new manufacturing unit for liquid paint manufacturing, like enamels and oil paints and clear coats, etc. So we have searched for the perfect chemist, because the chemist is the base for paint manufacturing, right? So we have searched for a perfect chemist, because if a chemist has perfectly got, then the manufacturing process will go smoother, and then the output will come in the quality. Otherwise, the local chemist will be there, even for 20K, 15K, and all, they are going to give a chemi, what do you call it, formulation and all, everything. But it won't work for a long time manufacturing. So we have keep on searching for that. Finally, we got Ramanathan sir in the internet research or something and all. So we have approached, but easily he has not given an appointment to even a meeting or over a phone call. So we have chased and we have got him. After that, we understood that how much knowledge person he is. He is a wonderful such a person. Actually, you can get interacted with him frequently to get in touch. You spoken to him for 20 to 30 minutes, you will get learn a lot of things. We are zero in chemistry, but after coming to Ramanathan sir, I thought of going back to study BSc chemistry. Chemistry is something like I thought some subject like history or economics. It's nothing to going to happen like that and all, I thought. But after that, coming to only in the paint industry, how much chemical is working, I was shocked. And then I'm trying to go back to college days, and then I wanted to study BSc chemistry. So that's why wonderful chemistry is it's a world market and it's a wonderful product. Chemistry is a wonderful product. I hope maximum I covered.
Okay, thank you. By the way, these girls, they have done some experiments just now, and they have been doing these experiments in the metal finishing for the past 4 days, and they will try to explain about their first hands-on experience in the metal finishing. So here let them explain one by one, so that it will be a very good narrative experience for you also. Yes.
Yeah, all the best, all the best.
You can sit comfortably. You can turn the camera. So one of you can stay here and sit. Kamali, you come here. You can explain how you started your venture.
Sure, sir. Hello, sir. Hello, sir. I'm Kamali.
Let's sound.
Hello, sir. I'm Kamali. I'm studying in Anadash College, second year, BSc Chemistry. And we came here to just start an internship project. And we started it on like metal coating. In such a way, we just started, we had an idea. So we just discussed with sir, and we just started putting our hands on this project. Today we started like by using this Asian Paints wood tech system. By using that, we now only studied about this base and hardener. Today we just started to study about it. So we started to learn about the viscosities and densities and flows of this hardener and base by using like a glass plate. We just confirmed and studied about the flow and viscosity of the both hardener and base. Then we learned about using thinner for reducing the viscosity of these liquids. So we mixed it and we learned how it should be and what the mistakes we shouldn't and what we should do for rectifying those mistakes. So we started to learn this today. So.
Very good. Okay.
Thank you, sir.
Yourself.
Good morning, sir. I'm Leena and I'm also studying in another college, second year BSc Chemistry. She said, we came here for an internship project. First, we didn't have any idea about coating or something. Sir only explained us about coating, which will be useful for us to avoid corrosion. And we started for doing epoxy painting using that resin. How can we protect our metals or any other things to avoid it from corrosion. So today only we started with flow test, and we came to know how the resin and hardener will be, how the flow to reduce the viscosity, how we can add the thinner, and what are the materials or their raw materials, and we started studying about that name and formulas of certain chemicals which we are using in resins and hardeners. So I think our project will be turn out into a very good one, and hope to see the final result of the project. Thank you.
Very good. Yes, Pavani.
Good morning, sir. I'm Pavani and I'm from Anadash College. As Kamali said, before starting the project, sir explained us about the basic concepts of resin and epoxy system. So first we studied about the chemical formula of epoxy resin. So how it is being formed and what are the chemical formulas and chemical reactions involved. And then we took down notes and we have written flashcards based on that. And after that we ourselves, this was a new experience for us. We ourselves went to buy the raw materials, and we got the raw materials from the different shops, and we gathered it and we planned accordingly. We planned a timetable for that, and for one day we spent for collecting the raw materials. We collected the raw materials, and first step sir told us this in metal coating we have to clean the metal before coating it. So first we cleaned the metal and we polished it, and then today we stepped into the flow test of the coating. So first, before stepping into the coating of metal, we tested the flow and the viscosity of hardener and the base, and we mixed it in the ratio of 1:1, and then we tested the flow of the liquid, and then to reduce it to the level of coating we added some thinner some amount of thinner to it, and then we test it. So now it's on the drying process, and after the test is being confirmed and everything is clear, then we'll start coating it on the metal. So we are continuing our project and hoping for the best results.
Okay. Thank you.
Thank you.
Okay. So now let me focus on the subject and what are the important chemistry about today's coating. I'll explain everything on board, and as usual our Pavani will also be that is helping me in drafting the notes also. Okay, so you can fix the camera in front of the board. So I'll be explaining about the concepts behind the today's. You can start from here. You please write something there. Start with epoxy polyurethane clear. Is it legible? Is it clear? Are you able to see
yes,
the
sir.
writings?
Yes.
Shall I focus more?
So today's class you will get in the written also, no?
Yeah, yeah. I'm recording now, don't worry.
Okay, sir.
Is it legible now? The handwriting on the board? Okay, I will read. Epoxy polyurethane polyurethane clear. So this epoxy polyurethane clear actually this consists of two parts. First part, you can mute on your side so that the audio will be better. Now, epoxy polyurethane clear consists of two parts. One is the base. Another is hardener. So here base is the that is resin. Okay, you can resin. The resin may consist of acrylics, epoxy, and other additives. Acrylics, ACRY. Acrylics, epoxy, and usually hardener will be of, there are two types of hardener. You can mention this as a TDI, and HMDI. The TDI is nothing but toluene diisocyanate. Toluene diisocyanate. So this is the urethane part. By combining this, you are able to get the polyurethane. Are you able to follow? Right. And HMDA is hexamethylene diisocyanate. Hexamethylene diisocyanate. So by combining these two, you are able to get a film, and that is called polyurethane film. By mixing in 1:1 ratio, you are able to get, and this is called PU coat. So here we are taken one day clear and that's why it's called PU clear. PU clear coat. Actually, this PU clear coat is applicable on metal, plastic, and some that is construction material, like you can put tiles also, glass and wood. So these are all non-metals and this is metal. Under metal we can classify ferrous and non-ferrous. You can bring our articles to be quoted. So here this is ferrous and this is non-ferrous. Open பண்ணிதான். Open. So ferrous and non-ferrous. In the ferrous, non-ferrous, you have copper, brass, bronze, even it can be coated on aluminium, galvanized iron, etc. In fact, a galvanized iron can be brought under ferrous, so you can put simply aluminium. So likewise, you can have various type of components over which we can give the clear coat. You may wonder why we should give a clear coat over the ferrous. In fact, this is going to be useful for the top coat. For instance, when you apply a paint, so probably that is, we have got a car like this, and probably they would have given some stowing acrylic system over this TSA. If TSA is applied, there will be some plastic components where the thermosetting acrylic cannot be applied. So in that case, these FRP linings and that is, we used to call it high impact polystyrene bodies and plastic components. So we have to match the color, and that cannot be stowed. So instead of stowing, they are using this PU finish, PU finish. So in such type of a PU finish, they can achieve the same performance as that of TSA. And finally, they used to merge everything as a one single top coat, and they can give this PU clear coat. This is also called the glaze coat, so that the overall glossiness will be improved. And also, it is a highly UV resistant, so that it will be very useful for you, especially for the body which is always exposed to natural climatic conditions, like weather, humidity changes, extreme weathers. So this is one of the best coatings recommended for any exposed material under hot climatic conditions. For example, in fact, we have applied on certain idols also, brass idols, bronze idols. Then you would have known such type of kumbam, So they are applied on kumbam also. This kind of tower which is fixed on the temples of India. And nowadays the cosmetic items, not cosmetic, the ornamental items and some artificial ornaments where I think there is this kind of brass items, you see. Will show. So this is not a coated, this is a normal one, and
Cleaned
this
one.
is cleaned one.
Cleaned and polished.
So this is uncleaned one, this is cleaned one. Can you explain how you are cleaned, Pavani?
Yes. We clean this using, first we clean this using a soap solution, and then we used a powder which is used to clean brass and all that puja items. So we have the brand name like Pitambari powder. we used to
Pitambari
call.
powder.
So using the powder we clean that, and after that
You can either use a Pitambari powder or
Samina powder or
lemon or even
tamarind.
tamarind. So the very idea is we have to remove the metal oxide. That can be possible only by using acid. In fact, we can use phosphoric acid also, but that will be more aggressive. These mineral acids are very aggressive. So instead of using that one, domestically you can use lemon.
we used lemon
And,
juice also, sir.
Yeah, so these things are possible. Only the reaction behind is we are removing the metal oxide so that you are able to bring out the virgin metal surface. Okay, our idea is the coating between the metal and the film should be very, very strong. I was talking about the two types of forces. Can you explain about that? Two types of forces when the drying is achieved.
Yes, sir. So the two.
I got that notes so
Yeah.
that you can explain based on that. The entire cord எடுத்துக்கோங்க.
Sir.
Hmm.
So
Keep it close.
basically, sir,
Right.
sir explained us about two types of links. That is
Polymer.
linear polymer and cross-linked polymer. So the drying process is nothing but when a chemical is in linear polymer and when it reacts with the oxygen, that is air, then it will become a cross-linked polymer like this. For example, if we can take a kerchief, if we remove the threads of the kerchief, then it will become a linear polymer. And if we combined it and stitched, then it will become a cross-linked polymer. As such, so when a chemical reacts with air, it becomes a cross-linked polymer. That's the drying process, and that's the process of paint.
Good.
So-
So drying mechanism is nothing but conversion of linear polymer
to
into
cross-linked polymer.
Okay. So in the case of air drying, it is an oxidative drying.
Yes.
It traps the oxygen from the atmosphere. So this is the regular drying, air drying enamels. And the drying process can be classified into three types. You can explain here. So the drying process can be classified into three. One is oxidative drying. Second is drying process. So one is oxidative drying, oxidative. The second one is drying by evaporation, evaporative drying. You can put evaporative. Third one is by stowing. Stowing, by heating, by applying heat, stowing. Fourth one is by curing with hardener, curing with the hardener. So normal enamels, air drying enamel is subjected to oxidative drying. It will take almost 3 to 4 hours for complete drying. And for thorough drying, it will take even 18 hours. So next day it may be ready for use. But in the case of evaporative drying, it hardly takes 10 minutes. So all kinds of auto refinishes, the refinishes for automotive industries, like automobiles, car, etc. They are using this type of evaporative drying paints. So they are basically NC lacquers, acrylic lacquers, acrylic finishes, quick drying acrylic. In fact, our Prakash is focusing on this kind of quick drying acrylic finishes. This is called thermoplastic acrylic. TSP you can put, thermoplastic. Prakash, we are going to formulate only this one for you. We are going to customize you.
Sure, sir.
And the stoving can take place, that is curing can be achieved by stoving only here. Here we are using thermosetting resin. Take out thermosetting resin. This can be either baked at, for example, that is 120 degree, or 150 degree. 150 degree. And in fact, if any epoxy system is there, it is baked at 150 degree. And if it is amino system, alkyd amine system, you can put alkyd amine. Alkyd is YD. Alkyd YD. Alkyd amine. So alkyd amine system here usually we take that is butylated melamine formaldehyde. So alkyd reacted with a butylated melamine formaldehyde. Such type of resins are used in developing thermosetting, that is stoving enamels. And here you have that is the TSA, thermosetting acrylic type with some epoxy. So this epoxy is essentially added in order to improve the corrosion resistance. Okay. So and the fourth variety is, that is, it is a 2-pack system. So if it is epoxy, pure epoxy based, then it is the epoxy amine system. You can classify into 2. Branch it to. One is epoxy based, another is PU based. So epoxy based will be, you can further branch it to 2. That is epoxy amine system. This is also available in 2-pack only. It means when the paint is supplied in 2-pack, it should be mixed only at the time of application of that paint. Prior to that, you are not supposed to keep it mixed because it will withstand only for 1 hour. So you have to plan in such a way within 1 hour, you have to take minimum quantity of paint and a hardener, mix it like what we had done an hour before. And then here epoxy amide system. Epoxy amide. And here we take polyurethane, that is 2K paint. So here we take the acrylic system plus isocyanate system. Okay. Polyurethane 2K, you can simply put 2K. Right? See, these are the essential items we should know. Okay, so can you summarize, Pavani, so that everyone can understand?
So drying process has four.
You can take a photo also so that we can send them simultaneously.
We have 4 methods in the drying process. The first one is oxidative drying, in which we use air drying enamel, and the next one is evaporative drying, in which the automobile industries and acrylic finishers use the evaporative drying method. And the third one is stowing. So the thermo-setting resin system, the stowing.
We use acrylic, and you can also put NC based lacquers, NC lacquers, nitrocellulose lacquers, NC lacquer, LACQUER, NC lacquers.
So and third one is stowing, where in thermosetting resin system we use stowing. At 120 degrees Celsius we use alkyd amine, and at 150 degrees Celsius we use TSA. And the fourth one is curing with hardener, in which we have 2 parts, that is epoxy based and PU based. In epoxy based, we have furtherly subdivided into two parts, that is epoxy amine and epoxy amide. And in PU based, we use 2K.
Now I'll explain what are the differences between these two. In the case of epoxy amine, this can be applied for interior coatings. Usually you would have seen this epoxy flooring. Okay, so where the industrial floorings are done using this epoxy type. So epoxy amine, and when you use any dark colors, you need not worry about yellowing, because when you take any amine, it has the tendency to become yellow. So for dark colors, you can use epoxy amine system. But if it is a very light color, okay, and also that is if it is exposed to UV, means then you can take epoxy amide system. Nowadays, in fact, that is epoxy amine system, it is prone to UV attack. So it should not be taken in the exterior side. And that is why within the tent, within the shed, within the industrial shed, it can be applied. But when it is exposed outside, means you have to go for epoxy amide, and that too with the UV resistant system. Okay, so these are all the more specified system. In fact, you would have seen some lorry tankers and petroleum tanker lorries, where you could have seen even water supply tankers. You could have seen epi-coated that is container. So this epi-coated container is nothing but epoxy system, so that it is a highly corrosion resistant. And this one is a polyurethane based. So this polyurethane based is a 2K system. Usually there will be a acrylic system, and sometimes it is epi loaded also, epoxy loaded, in order to be corrosion resistant. And along with that, we supply this as a hardener, and that hardener is the two types of isocyanate I was explaining. So this is toluene diisocyanate, another is HMDA. In toluene isocyanate, it is an aromatic system where this hardener has the tendency to become yellow. So in the case of, but it is a fast curing. But when you have got epoxy, I mean, what do you call this, HMDI, it is somewhat less, curing. I mean, it cures well, but the thing is, it takes more time. It is not so fast, it is slow curing. But it is able to withstand, that is UV, attack also. So that is why we are very, very specific about such kind of systems. And you could have seen even the decks of ships, where the anti-skidding is required. You should not be slipped. Okay, so when any weight is being carried, and the passengers and the other people, the mariners, they should not get slipped. So in order to avoid this slipping, because there will be some oil seepage, etc. So they used to coat the deck of the ship with such kind of heavily loaded, that is anti-slip coating, coating. So these are all very, very industrially popular one, and sometimes that is nowadays they are using is in a variety of way. And as I was talking about this, polyurethane clear. So this polyurethane clear is a wonderful finish. Usually hardness and flexibility, both of them are almost that is extreme. When the material is hot, it is brittle. Is it not? So when it is extremely hard, means it is brittle. And when it is extremely soft, it is flexible. So our idea is to achieve an equilibrium between hardness and flexibility. There is one resin that is both kind of hardness and flexibility can be achieved only in polyurethane, and that is why polyurethane is used in soles of shoe. You could have seen sandals and the shoes, where they used to have this kind of polyurethane sole. So you have got the toughness as well as the flexibility. Are you able to follow? So in today's class, I was explaining about the polyurethane epoxy clear. Actually, it is called polyurethane clear. But this polyurethane, and how was your experience when you handle, so that because just now they have done this experiment, and probably they would have struggled even with flow. Okay, so I will explain why we have conducted this flow experiment. And before that, you just narrate your experience when you handle this liquid, how pungent it was.
So the fun part, apart from the fun part of chemistry, we were okay. Chemistry has a different kind of experience. We experienced the real chemistry today actually, because in our school or in our colleges, we just used to handle the chemicals with the test tubes and like, so it was very basic school-based chemistry. So first time we experienced and we handled chemistry using our hands. So the thinner was very irritating in our hands. So we were very scared. Oh my God, it's very irritating, sir. Nothing will happen. Just wash your hands and apply some oil. It will be okay. So we were very scared. Okay, this thinner is causing such a irritation in our hand. What happens if it pours in our body? So we were very
How about
scared.
your nail polish? Is it there?
No, we don't use nail polish.
Luckily you didn't use.
Didn't use it.
Otherwise everything would have been wiped out. Because
That's what I
such a
say.
very strong liquid.
That's what I was saying while using the thinner, so it just removes the nail polish.
Actually, that is, we recommend all people, especially girls, not to use the nail polish, especially when you handle any chemicals. Okay, even colleges are used to advise about these girls, they are least bothered about that.
No, so
After
they are
they
not
are
using
not,
us.
no, they are not handling with such powerful solvents.
Yes,
But when
sir.
you come for R&D and quality control laboratory and research institutes, research laboratory, definitely you might have to use some very powerful solvents. And what do you think about this thinner and how you how about the opening of this paint and hardener?
So, when we opened the box of base and hardener, it was sticking in the hand and it caused a very rough layer in the hand. So that was not we were not able to peel it off with the hand, like, or wash it off. So we used thinner to clean that, and the thinner caused irritation. So everything was
No, it was a live experience.
experience. Yes, sir. That was very interesting and as well as scary. Okay, this every chemical has a unique property. So, and for metals it is a good thing, and for human hands we should handle it very carefully.
Because we are expecting, actually that is this kind of polyurethane clears can be applied for even that is archaeologically significant, we used to say inscriptions like a culvert,
Yes,
then that is a
That-
copper things, you know. So all these architectural and archaeological things can be coated with this, and thereby we can protect. In fact, there is a general inquiry from these departments to me regarding that is additional protection of, so because they used to, for example, when you find any culvert in an old temple, you know, these guys they go and further crack.
They inscript their own things.
And there are some epoxy based clear coats are there. You cannot simply scratch it.
scratch
It is
it.
scratch proof.
Okay.
Our system is totally scratch proof. You cannot write your name, so and so pass, I love you, etc. All these things cannot be done. All these monkey ways of writing on monuments, you know, these are all, these should be protected. So we should protect, and we should not write anything such silly things. After all, they were preserved for years together, almost 2,000, 3,000 years old. I saw in what you call, there is one place near Pudukkottai where they have got Chittanna Vasal Ovium is there. They have done all these mischievous things. So I suggested the people also to give a protective coating. And even nowadays they have put some barricade, etc. But previously you didn't find any such type of a barricade and fencing.
Yes, sir.
And now they have put some fencing. Anyway, that is there is always you have to protect. In fact, that is we have applied such kind of coating in that is amusement parks where you can see waterfalls, you know, artificial waterfalls. Even in I think in Kishkinda they had some. Now it is closed, but
Yes.
previously there was a fun called fun park called that is Chennai Kutralam, like that. So they developed artificial rocks, and over which we had given our own epoxy and polyurethane based coatings. Okay, so such a nice finish was there, and it is highly water repellent also. so it will not erode the rock. So even for that is any beach concrete works, this kind of systems can be applied. So this is a very powerful. You just imagine yeah, we are handling a system which is very powerful and which can withstand even for that is almost years together. So in that case, how can you expect a soft film formation on the hand? It will be very tough. So unless otherwise it should be removed, it is very difficult immediately. Okay, so you have to remove it immediately using the same solvent. Okay. And usually such type of epoxy system, that is we used to add the best solvents or diacetone alcohols, then cellosol, butyl cellosol, ethyl cellosol, and you can add some xylene also. And there are some true solvents and diluents available for such kind of systems. And in order to adjust the cost, we can add a proportional mixer of such type. So when you want to check the clarity and the cleanliness of the coating, you have to necessarily do this flow experiment. So in fact we have done this flow. So can you explain about this flow experiment? Come on. We did one important flow experiment. How we did it? Just explain.
So like first of all, we learn how to like unseal the pack. So we are not supposed to shake it like.
Assuming that this is the glass plate, because we have kept this for drying temporarily, because we are reproducing all these video to you later. But meanwhile, you can consider this as a glass plate, and you explain how we did this flow.
Okay, so
test.
like first of all, we have to unseal those like wood tech system, which consists of a base and a hardener, and we are not supposed to shake it like we used to shake in nail polish or something, and it will burst out like an air filled like juice like soft drinks. So we are not supposed to shake it like very heavily. We are not. We have to like shake it very gently in an up and way manner. Then we have to unseal it like very gently, because it may just flow.
Yeah, no, this part is very important. Anyway, I explained to them. See, that is usually we had the, a habit of mixing a liquid like this. But we should not do such type of mixing in solvent based, especially organic solvent based. This is very dangerous. It will almost explode like that is any frenzy liquid. So you have to tumble like this. So this is called tumbling. So you have to tumble. Okay, right.
After unsealing all those packs, we have to start our flow test. First, we have to take a glass plate or a glass sheet. We have to clean it first using a thinner to remove all the dust and our handprints on those glass sheets. So we have to use a thinner by using a cotton cloth. We have to clean it completely. Then we have to take a dry cotton cloth and we have to clean it, the thinner marks on it. So then we have to keep those glass plates apart to dry. Then we have to take a little amount of base in a container or a beaker, and then we have to like shake it gently, and we have to, by keeping this glass sheet flat, very flat, and we have to pour a very little amount of those hardener, and we have to gently tilt this glass sheet, and we have to take out those remaining falling excess part from those glass sheet. And the same way we have to mark it first of all. Then the same way we have to take another beaker. Then we have to use base, and the same way we have to keep it very flat, and we have to pour a very little amount of hardener in it, hardener base. Then we have to tilt it and take out the excess part from those glass sheet, and we have to keep it apart to dry. Then we have to mix both hardener and base with 1:1 ratio, which makes the proper flow test, and which is the proper way of doing it. We have to mix it in 1:1 ratio in another beaker, and we have to take another glass sheet, and we have to, same way, we have to keep it in a flat way and pouring a little amount of both mixture of base and hardener, and we have to tilt it to get the excess amount of hardener and base, hardener plus base out of this glass sheet. This also we have to mark it plus by base plus hardener in the ratio of 1:1. Then we have to take those base plus hardener by adding some amount of thinner to it to manage the uh, viscosity of those base plus hardener. Then we have to take another glass sheet and we have to mix it properly using something like stirrer like that. We have to mix it properly, completely those base plus hardener plus thinner. Then we have to take another glass sheet and we have to keep it very flat, and we have to pour a little amount of those base plus hardener plus thinner, and we have to tilt it. We have to collect the excess remaining, and we are keeping all these 3 glass plates to dry, and that's what we done till now.
Okay, good, great. Now I will explain why we are doing like this. For example, we have the plate like this, glass plate. What is the dimension of the glass plate now we have taken?
4x6.
4 by 6. So this is 4 inches, this is 6 inches glass plate. And here the first flow down like this, the next flow down like this. This is called flow of liquid, and the next flow like this. So this is base only, this is hardener only, this is base plus hardener, and the fourth one you can take, and this is base plus hardener plus the required amount of thinner. So you have to check the flow of, this is called flow tests. So you have to check the flow test of all these flows. And if there is any clarity or dust, it can be seen here itself. In fact, all these experiments should be conducted in a dust-free atmosphere. And when you keep this overnight, you can observe, immediately you have to observe if there is any blooming, because you may not know the material you have purchased is up to the mark. It means that is up to the standard quality. Whether it is old stuff or new stuff, probably that is, we may not be aware of the date of expiry also. Sometimes they used to tab also. So you have to be very careful about your raw material or your product. And if it is a old one, affected one, you can see the bitterness here. But when it is applied on the wood, it may not appear immediately, but after drying, it will give you a dusty finish. The same dusty finish can be seen if it is not all right. Immediately in the full flow test, because the people will say, suppose if you are the metal finisher, they may say the dust has caught. So it is not a question of catching of dust. It is because of the presence of extraneous material in the clear itself, in the finish itself, in the material itself. Probably the base itself, there may be some undissolved or previously reacted material. Okay? And even in hardener, sometimes you can have some bloominess. Blooming, that is, you should know what is blooming. Blooming is a hazy part of the inner part of the grapes, in the grape peel, you would have seen that, what you call the turbid like hazy layer. So such type of blooming is appearing here. Immediately you can say that it is not a good one, it has been affected. Okay, so you have to be very careful. And by combining this, suppose if either of this is adulterated or spoiled, then it will come out as a big particle here. Okay, and when thinner compatibility is not there, then again it will form a bitterness. It's called bitterness. Bitterness means dust particle collection because of some pre-reacted components. Overreacted, pre-reacted. Okay, so before curing, sometimes in-can curing, it's called in-can curing, and some extraneous material would have been there. Okay, so these are all faulty finishes. If it is a good one, all should be transparent, water white. Water white means what? Totally clear. There should not be any white patches. Okay, so this is a very, very important test. I recommend this for any kind of resin, not only for clear, for any resins, any polymer, you have to necessarily conduct this test, and this is called flow test. And there is a separate standard for this in ASTM also. I will let you know all those details in my next course of lectures. Okay? So if you have got any doubt, you can get it clarified. Prakash, do you have any doubt in today's session? I will be sharing the video part later. I mean, whatever we have done in the experiment as done. Any doubts?
No, sir, not yet, sir.
Okay, Surendra, do you have any doubt?
Yes, sir. I have lots of doubts, but sir, I cannot understand. This is my first course about chemistry. So, if you provide all the in written and video, then I will be reading it 2-3 times, and I will ask the questions. Sir.
Yeah. I will share with you the handwritten notes also, so that you can comfortably go through that, and you can try to understand the chemistry behind. And these are all the general operating procedures only. We used to call SOP, standard operating procedure, to handle such type of chemicals, especially in case of flow test, and how to deal with the resinous liquid. Okay.
So this flow test is we can check for resin also, clear coat also,
Yeah,
and for emulsion
the
also.
same is applicable for resin purchase also. After purchasing the resin, you have to necessarily do this kind of flow test essentially.
Okay, sir.
Because resin is the heart of the paint industry. So your quality of the paint is dependent on the quality of the resin.
Okay, sir.
Okay, so we will continue our lecture in the next class. Thank you so much for your patient listening. Bye.
Thanks.
Thank you so much.
Okay.